Welcome to Brain Vision.
In this problem, we have a block with a given mass that is released from rest a distant h above a plate. The plate is connected to the ground via a spring with a given spring constant. We want to calculate the velocity of the plate just after the block has collided with it. So before impact for block A, we can apply the conservation of energy. So for block A, before the impact, if we apply the conservation of energy, we know that the initial kinetic energy of the block plus its initial gravitational potential energy is equal to its final kinetic energy plus its final gravitational potential energy. So if we take the plate to be the datum, its initial height is h above the plate. And so initially it has gravitational potential energy mgh due to its height h above the plate. And this gravitational potential energy is converted to kinetic energy when it reaches the plate. So that's a half m VA squared. So if we rearrange the equation, we see that the masses cancel on either side. We get that the speed of the block just before it strikes the plate, VA, is equal to the square root of 2gh. So we'll keep that in mind. And now we'll take the downward direction as positive, and we'll apply the equation for the coefficient of restitution, E. E is equal to the final velocity of the plate, VB2, minus the final velocity of the block, VA2, over the initial velocity of the block since the plate is at rest, and this is square root of 2gh. So if we rearrange this equation, we get that the coefficient of restitution E times the square root of 2gh is equal to VB2 minus VA2. We'll call this equation 1. So essentially we have two unknowns here, which are both the final velocities of the block and the plate. Now if we again take the downward direction as positive and apply the conservation of momentum, that is the momenta before the collision must equal to the sum of the momenta after the collision. So initially we have momentum mVA. The block has initial velocity VA and the plate is at rest. Finally, we have momentum m times VA2 plus 2m VB2. That's the momentum of the plate after the collision. So we'll call this equation 2. Now we have two equations with two unknowns. We can see here that the masses cancel, so we're left with just the final velocities. So if we solve equation 1 and 2 simultaneously, we can find the final velocity of the plate after the collision. So with a bit of mathematics, we get that the final velocity of the plate after the collision, VB2, is equal to 1/3 times the square root of 2gh into 1 plus the coefficient of restitution, E.